Recording in progress. Hi students, in the last lecture I have discussed kinematics of circular motion. Let us now continue. Definition of omega, rate of change of angular position with respect to time, units, dimension formula, direction along the axis, motion is clockwise, then direction inwards, anti-clockwise outwards. And definition of alpha, rate of change of angular velocity with respect to time, direction along the axis, units radian per second square, dimension formula t power minus 2. Let us now continue. Right. Now here, if we take velocity, speed is a constant. When speed is a constant, we know speed equal to r omega. Speed constant means omega also constant. Speed constant means omega also constant because r is a constant. So when speed is a constant, it is called uniform circular motion. It is known as uniform circular motion. Now speed constant means tangential acceleration is zero because it is the rate of change of a speed with respect to time. Next, omega constant means, or it means directly, at 0 means r alpha 0. That implies alpha 0. Alpha 0 means omega constant. So we are saying that speed is a constant. It is uniform circular motion. Means at value 0, alpha value 0. If speed is changing, then it is a non-uniform circular motion. So whenever speed is a constant, acceleration means only centripetal acceleration. So A equal to AC. So we can say in uniform circular motion, acceleration is variable, but modulus of acceleration is a constant because direction is always towards the center. That is keep on changing, but modulus value not changing, right? Let us now solve problems based on kinematics of circular motion. Let us see the first one. A particle moves in a circle of radius 10 centimeter. Its speed is given as v equal to 3t meter per second. Find its acceleration and also angle made by it with velocity vector at t equal to 3 seconds. So you can see from this given data, speed is changing with the time. That means tangential acceleration is non-zero. Radius given 10 centimeter, we have to find acceleration. Also angle made by that with velocity vector when t equal to 3 seconds. Let us see. Let us see now. Given v equal to 3t. From this we can say that when t0, speed is 0. And ask me when t equal to 3 seconds, what is acceleration? Means we want modulus value, which is nothing but square root of AC square plus AT square. Okay. Right. Let us see how to find AT. AT is nothing but definition is a rate of change of a speed with respect to time. Here V stands for speed, that is equal to 3. So it is now constant. Okay. Next, coming to AC. AC equal to V square. It is V square by R. Right. It is equal to V square by R. and finding v value when t equal to 3 seconds, right? So simply substitute now in this t value 3, right? We get v value 9. So it is now v value 9, so 9 square, r value given 0.1 meter. So 9 square 81, 81, this is 0.1. It is 810, right? 810 meter per second square, right? So now we got AT value and AC value, right? So V value, how much we got? 3 seconds means 9. So V square by. So now we can take AC square plus AT square. We get the value of acceleration at modulus 1. And to find angle made by acceleration vector with velocity vector, I am making diagram here. This is AC towards center and this is AT along a tangent. Now this makes angle. This is resultant of those two, which is nothing but acceleration. Angle made by that with velocity vector. Direction of velocity vector and tangential acceleration both are same because here speed is increasing. Speed increasing means AT and V bar are in the same direction. So asking with velocity vector or asking with direction of tangential acceleration, both are same. So that I can take it as, if I'm taking that as beta, tan beta is equal to, tan beta is equal to AC by AT. Okay. That means AC value 810 and AT value 3. So AC 810, this is it. That means beta equal to tan inverse 810 by 3. Okay. So directly we can solve it. Let us see next one. A point mass moves in a circular path of radius 1 meter with a constant angular acceleration of 4 radian per second square. Alpha is given, r is 1. T equal to 0, speed of the particle is 0. Find at what time the magnitude of the tangential acceleration is equal to that of the centripetal acceleration. We have to equate their magnitudes at AT equal to AC. At what time? At what time? Given alpha and r. Let us see. Alpha given 4 radian per second square. Sorry, 4 radian per, right. So at what time AC, modulus value of AC, modulus value of AT are equal. Alpha given 4 radian per second square. V equal to 0 when T equal to 0. Right. That implies omega also 0. So AC means I can write R omega square. That is equal to AT. AT means I can say R alpha. R gets cancelled. Omega square. Omega means it is alpha T, right? Alpha T whole square. Because omega 2 equal to omega 1 plus alpha T. When T 0, V 0. V 0 means omega also 0. That's why this is equal to alpha T. So alpha T whole square equal to alpha. That means alpha square T square. So T square is equal to 1 by alpha. So T equal to root of 1 by alpha. And alpha how much given? 4. That means it is now 1 by 2. Means when T equal to half second, their magnitudes are equal. Okay. See next one. A point mass is at a distance C from x-axis and is moving parallel to x-axis with a constant speed v. find its angular velocity about origin at the instant when its radius vector makes an angle theta with x-axis. Okay, let us see how to start the problem. We have to find omega about origin, speed constant. That means exactly here given velocity constant, right? Okay, see how to start the problem. First, note down the given data. The point mass moves parallel to x-axis. Given distance equal to a, right? Speed is a constant. Speed constant means definitely direction not change, right? It is moving parallel to x-axis condition given. That's why I'm saying velocity constant. It is v. Now he's asking omega about origin when radius vector, or you can say radius vector, makes angle theta with x-axis. Okay. So first of all, question comes when we can speak about angular velocity, the word. So whenever radius vector rotates, there we can speak about angular velocity. Okay, here you can see when this is moving, the radius vector about origin is now rotating, right? It is a keep on rotating. So we can speak about angular velocity. And that is given by, see how we can do. When we are discussing circular motion, we have learned that velocity is always along a tangent, right? Means it is always normal to radius vector. So we have to focus now. Here omega means V by R. So we are finding velocity component normal to radius vector. Divide that with radius vector. Okay, modulus value. So here I'm taking the same logic. For velocity, I'm taking two components. One is normal to radius vector and one is along radius vector. So this is theta means this also theta. Along radius vector v cos theta. Normal to radius vector v sin theta. You can see here. This velocity is normal to radius vector. That velocity component by radius. That is omega. Therefore here, if this distance is r, omega about origin is equal to v sin theta upon r. Okay. Now from diagram, getting r value in terms of it, we can see from diagram, tan, sorry, not tan, sin theta is equal to opposite by hypotenuse. So from this r equal to a by sin. So this becomes v sin square theta upon a. Okay. Like this, we can find angular velocity. Okay. I hope you got clarity. Let us see next one. This is a previous IIT question asked in 1987 for 2 marks. See once what is given. A spotlight S rotates in a horizontal plane with a constant angular velocity of 0.1 radian per second. The spot of light P moves along the wall at a distance 3 meters. What is the velocity of the spot when theta equal to 45? This is given upper view means top view. This is wall. Given distance equal to 3. This angle is now theta. Let us see what is velocity. Given 0.1 radian per second. First, write down given data, omega value 0.1 radian per second. Distance of the wall that is given 3 meter, right? Let me make a diagram here. This is wall. This is now that spot. This is the spotlight. Now this light is falling on the wall. This is given as theta. And this distance is given as 3 meter, right? Okay. Now see how to find velocity. Let us assume parallel to wall as x-axis and normal to wall as y-axis. Okay. So we have to find when theta equal to 45. What is velocity of the spotlight on the wall? This is the given data. So first we have to think like how to find velocity. So we are knowing that definition of velocity is rate of change of position vector. I can write here position vector as v bar equal to, before writing that, let us write r bar. Position vector is r bar equal to x I cap plus yj cap. We can see clearly in this, its y coordinate is not changing. This spot is only, in this we are given that it is rotating clockwise, right? This spot is moving along x-axis. So its y coordinate is not changing. Therefore, derivative of y becomes 0. So velocity means it is now only derivative of x coordinate. So this velocity is nothing but Vx into y cap. Okay. So Vx is now dx by dt. So first we're starting, right? Definition of velocity, rate of change of position vector. We got position vector, and in that we are knowing that y coordinate is not changing, only x coordinate changing. Therefore, take only derivative of x coordinate. So velocity is nothing but x component of velocity. And from diagram, you can see x value how much. If this is x, I can write tan equal to tan theta equal to 3 by x. That means it is a derivative of it is x is 3 cot theta. Okay. So I'm taking 3 outside, derivative of cot minus cosecant square theta into d theta by dt. Okay. And you can see here in the diagram, x coordinate is increasing. So definitely this value must be positive. Okay. And if you observe, when it is rotating clockwise, this angle decreases. This angle decreasing means d theta by dt itself is negative. So negative of negative positive. So this is now 3 minus cosecant square theta. Since angle 45, it is 2. In the place of d theta by dt minus 0.1. It is very important because theta is decreasing. Minus minus plus 6, 0.6. 0.6 meter per second. Okay. Like this, we can solve it. See the next problem. A particle moves in a circle in such a way that its magnitude of radial acceleration is equal to that of tangential deceleration. If the initial velocity of the particle is v naught, find the variation of its velocity with time. This is a tangential deceleration and this is acceleration towards center. So we have to find velocity as a function of time. Now see how we are going to start. So first of all, write down given data. Modulus of AC is equal to modulus of AT. Okay. AC value V square by R. AT value, modulus value. Since given tangential deceleration, it is dV by dt. This itself is negative. So to make it a positive, taking a negative sign. Okay. Now from this, see what we can write. We can write it is dv by v square is equal to minus dv by v square equal to minus dt by r. Check it once. I have taken v square here, dv by dt here. Okay. Now integrate. And condition given that initially when t equal to 0, velocity v naught. So while taking integration, we should be very careful while taking limits. So when time t0, v naught, at time t, it is v. Now this is 1 by v square, or it is v power minus 2. V power minus 2, integration is now v power minus 2 plus 1 by minus 2 plus 1. That is minus 1 by v. Minus 1 by v limits v naught and this is v equal to minus t by r. Okay. So it is just writing the given condition, nothing else. I think we can cancel minus, right? If you cancel minus, remaining is not take limits 1 by v minus 1 by v naught equal to t by r. So from this 1 by v equal to 1 by v naught plus t by r. Now simplify this. V equal to v naught r upon r plus v naught t. This is our final answer. Okay. So I hope you got clarity, especially here why we have taken minus. It is given tangential deceleration. It is negative. So negative of negative positive. Because if you are missing this sign, we'll get different answer. Okay.